can see, I'm a math tutor here at Wyzant answering a question submitted by a student. And it has to do with finding the range of this expression here. This is a ratio of polynomials, and any ratio of polynomials is called a rational expression. And this is something that you should learn in Algebra 2. So here's our rational expression here. And what I'm going to do is just factor the numerator and denominator. So I'm going to get x plus 2 here, and then x minus 2 here, and then divide and factor this. So it's going to be x plus 2, x plus 3. So now we can cancel these, and we're left with x minus 2 over x plus 3. Provided, of course, x itself cannot be negative 2, because when x is negative 2, the denominator becomes 0, and we have something that's undefined. So negative 2 we know is a whole. So we know that we have a whole at negative 2, but we have some other things going on here as well. So that's our whole. Now if we look at our reduced expression or simplified expression, you can see that it has a vertical asymptote at negative 3, because if x is negative 3, the function is undefined. So we have a vertical asymptote at negative 3. X equals negative 3. And we'll fill in the hole in a second. The other thing that you test, what you're really testing for are horizontal asymptotes, vertical asymptotes, holes, and it's traditional to look for a x-intercept or a y-intercept if there are such things. So we did our vertical intercept, horizontal asymptote, sorry, vertical asymptote, horizontal asymptote. Because this degree is the same as this degree, the degree of the numerator is the same as the degree of the denominator. The horizontal asymptote is the ratio of the leading coefficients, which is y equals 1. So now we have y equals 1 is our horizontal. And now we have to sketch. And the only way to sketch really is to plot some points. Hopefully we won't have to plot too many. I'm going to start off with the origin when x is 0. So you can see when x is 0, y is negative 2/3. So we have a point that looks like that. And so this tells me that the curve is going to run. Well, let's find another y-intercept. So that's a y-intercept when x equals 0. Is there any other one? That's the only one. Okay, I think maybe we'll plot another point. Say when x is 1. When x is 1, this is going to be negative 1 over 4. So when x is 1, it's negative 1 over 4. This was negative 2/3. So this is negative 1/2. So it's slightly not as negative, not as far negative, 1/4 versus 2/3 point. So it's coming up slightly. So that tells me we have, and we only have that y-intercept once. So it tells me that the curve is going to look like this. There's no other way you can connect those two points in the middle and also respect these asymptotes. Now if we go over here, we'll go on this side, maybe negative 4 for x. Let's try that. So negative 4. So that's going to give me negative 6 over negative 1, which is 6. Negative 4, 6 over negative 1. Yep. So negative 4, I'm at 6, so I'm pretty far up here. And once again, there, because of the asymptotes, you have to have something that's going to be asymptotic vertically and horizontally. So the horizontal here is pretty clear. It has to be out here, and so this arm of the graph has to look like that. Oops, sorry, I'm having trouble with my drawing tool here. Okay, and now we just need to worry about the hole. So the hole is at negative 2. So at negative 2, the hole is in here. Let's just make room for the hole here. We'll stick it in. And we'll stick it in like that. Oops, I don't know why I did that. This is asymptotic, of course. Now, if you wanted to get the exact position of the hole, you would just put negative 2 in here. So it's going to be negative 4 over 1. So this would be, this hole here would be negative 2, comma, negative 4. You might want to get the x-intercept here. Sometimes teachers want to see all these things. I think in this particular instance, we don't have to bother because they're only interested in domain and range. Actually, they're only interested in range. But I just don't see how you do this without a graph or sketch. So let's go ahead and do range here. Okay, so y clearly gets infinitely negative here. So it's from negative infinity up to the hole, which would be negative 4. And then union. So we went from down here, down this asymptote. Oh, you know what? We also have to have this arm here. So that doesn't affect us yet, but when we come over here, we have to allow for this other arm. So this is going to come very close. It's going to negative 4 to 1, but you see it won't touch 1 because that's an asymptote. And then we have to deal with this arm last on the range. So this is going to be 1 comma infinity. So that's a little tricky. So there are 3 intervals there that we need. I don't know exactly what the student did here. I'll leave that for somebody smarter than me to negative infinity to 1. So you could see he didn't account for the hole. He got the upper part of the arm right, but he missed the hole. So that seems to be where he went wrong. But this is something you should get good at because rational expressions are all over Algebra 2. You'll see them again, believe it or not, in calculus. And then you'll also see them on ACT and SAT. So you need to get good at this and learn all the rules for the horizontal asymptote, vertical asymptote, x-intercept, y-intercept, and then you'll be able to do a sketch and answer these questions. Okay, that's it for this problem. See you next time. Bye-bye.